Hi everyone, welcome to our event. So this is a workshop, and in this workshop we will see how to use DVC, how to use GitOps practices for converting Jupyter Notebooks to pipelines. Now the floor is yours. Please start.
Sounds good. Thanks. So thanks for having me, of course, and thanks everyone for joining for the session. Today I'll be talking about GitOps for ML. So going from a notebook to a reproducible pipeline, as you've probably read in the description. We'll be doing so using DVC, which is an open source library. Stands for data version control, but as we'll see shortly, it does a lot more than that as well. So I think without further ado, let's just dive right into it. I'll first give a short introduction to DVC and why it's useful in circumstances like these. Then we'll go through the workshop together. So I hope you've got your terminal and your IDE all set up so that you can follow along. The first part of the workshop will entail converting the notebook to a DVC pipeline. And then if we've got any time left, we'll take a look at how we can take the model training for our new pipeline online with CML, which is CI/CD for machine learning. But more on that later. For me, when I start prototyping in a notebook, when I start prototyping a machine learning project, I usually start out in a notebook. It's easy to set up, start on the fly, be able to go back and forth, change a few parameters here and there. But inevitably, the notebook grows too big. It becomes a bit uncontrollable. My kernel keeps dying. I was actually experiencing that earlier today while preparing this workshop. So that's where DVC comes in. First about me, just a very short intro. I'm from Utrecht in the Netherlands. Up until recently, I was working as developer advocate for Iterative. And as will come in later, I'm a water Pokemon trainer. We'll be using a notebook that creates a classifier for Pokemon sprites. Your typical notebook, you've seen this 1,000 times before. First you do your imports, then you probably do some data cleaning, preparation. From there on out, maybe your model training, and then some evaluation of the model to start some metrics. To find your metrics, maybe a confusion matrix, whatever you're optimizing for. And this works quite well as long as you are going all the way from the top, all the way to the bottom, and you don't get that kernel somewhere in between. But at the point where you do get to the fully working prototype, you still can't quite start using the model. We have our model at this point. We can classify whether a Pokemon is of a water type, but then something happens, something in the real world that affects how your model performs. So for example, in this Pokemon classifier, 2 new Pokemon games got released last November. I haven't played them thus far, but that changes the composition of our data set. And this is something you'll see time and time again in whatever machine learning context you may be working on. Something changed in the real world that results in new data sets. You may introduce some drift. The model has a changed performance and it may need retraining. So even though we had a working prototype in our notebook, something happened and now we need to change the prototype. So in machine learning, we've got a process for this, and that would be experimentation. So we tweak some parameters on the fly. So here we change our data set. Maybe we can take a look at the number of epochs. We can change some weights, some other stuff. We may be interested in training for a new model, for a new Pokemon type. So maybe in the latest Pokemon release, I want to be a fire type trainer. All that kind of stuff. You've seen all the hyperparameters yourself. But as you do this and you try to keep track of those experiments you're running, you can get lost in which experiments you had run. So for example, I trained this model for classifying fire type Pokemon, but what were the precise combination of learning rate and the number of epochs for that? And how does it compare to the other one? So we need a structured approach towards this experimentation. And that's so that we can achieve reproducibility of our experiments. So if I do one thing at a certain time and I do the same thing at another point in time, then I should get the same results. Otherwise, there's randomness. We can't reproduce our machine learning experiments. We don't know which experiments perform best. So what do we need to achieve that reproducibility? if we want to reproduce an experiment, we need to be able to reproduce our data, our code, and our parameters. So the data sets, that's the one that changed in this specific example. The code is something that we can reproduce. That's been a solved problem for a long time. We use Git for that. And the parameters are also largely text files. So we can also use Git for that. But the data set is the tricky part. And also the resulting models, because those files are deep. So if we've got Git for text-based files, then what can we use for the large files? And that's where DVC comes in. Originally started out as data version control. What it does is it ties your the versioning of your files, your data sets, your models, to your Git commit history. And it's got three main features, which we'll briefly discuss. So first of all, data version control, then pipelines, and then experiments. And yeah, it helps to understand how the data version control works before we dive straight into pipelines and experiments. So data version control first. Imagine you have a Git repository. So these are our commits going up. We've got a feature branch, and in the feature branch, we have a data set. So here we have 3 Pokemon in that data set. And that works well enough, except when the image files are quite large, because I think GitHub has a 50 MB limit to the files you can upload, roughly similar for GitLab. Git isn't meant to store large files. So what can we do with DVC? We replace those image files or our data set with a metadata file. And the metadata file includes some metadata, such as the hash, the size of the data sets, and the number of files there. And we place that metadata file in our Git commit history. We then use that metadata file to point towards something in our DVC cache. So the DVC cache is something that DVC creates. What it does with it structures the image files in there in a certain manner so that DVC can retrieve those image files or any other files that you may have as you need them. So for example, here we have a data set of DVC, and it points towards this point in the DVC cache, and DVC knows how to or can resolve that to the proper image files. And this is called ref link. So the funny thing about this, or the nice thing about this, is that once we get a new Git commit with an updated data set of DVC, it can point towards some other stuff in your DVC cache. So here, for example, we removed the bottom Pokemon from our data set, which is Omastar, I believe, and we added Charizard to our data set. And the other 2 Pokemon here, those are still only once in our DVC cache. So we don't need to duplicate our data, even if we have incremental changes to our dataset. And then, of course, we can mirror that to a remote storage, as we'll also do throughout the workshop. So that DVC doesn't only live on your local system, but you also have versions, much like you would version, or you would mirror your Git repository to GitLab or GitHub or Bitbucket or self-hosted solution. So that's in a really short description how DVC roughly works. Now let's take a look at pipelines, because we can use the way DVC versions your data files in pipelines. So this is roughly the same as we saw in the notebook, or I described for a notebook. We first do some data pre-processing, we then load in the data, we train our model, and then we evaluate it to see how the model performs. And for those of you who may be aware, this can be described as a DAG. So we start at one point, and the subsequent stages only trigger as the previous stage is complete. All of these stages result in a number of outputs. So for example, for the model training stage, we have a model as a result, and also a bunch of plots that show how our model training went. I see a question about the difference between MLflow and DVC. I'll keep that for a little bit later, if that's okay. Then the outputs of a previous stage are the inputs for a next stage, or we can at least tell DVC that, hey, only start data load once the dataset labels and dataset images are created in DVC cache. And so by means of that, DVC knows how to, or at what point to start the next stage. And we can assure that they all get processed in a subsequent manner. So if we have that pipeline in place, and we know that all of the stages follow up on each other, and we can always reproduce the same pipeline results, we can start experimenting. So we have a number of inputs and we have a number of outputs, and our DVC pipeline somewhere in the middle. So our inputs are the stuff we needed to reproduce the experiments, the code, the data, and the parameters. And we do something with those in the pipeline, and it results in a bunch of outputs, the model, the plots, and the metrics in this case. All of these are versioned by either Git or DVC. So roughly speaking, if it's a text file, you version it with Git. If it's not, then you version it with DVC, just to keep the file size small. And if we take all of this together, we can consider this an experiment, or technically speaking, we can consider it a Git commit. All of these together, we can then go back to a different Git commit, reproduce those results. So we jump back and forth, as you can see here. So for the previous experiments, we had a bunch of different parameters that resulted in different outputs. So because the parameters changed, our model, plots, and metrics also changed. And with just a single command, or two, depending on how you set it up, Git checkout and DVC checkout, you can easily switch back and forth between those. So no longer you need to keep track of your experiments on sticky notes to determine which combination of the three inputs resulted in a given model performance. That's the high over of what Git and DVC together can accomplish. And I think we'll spend the remainder of this workshop setting or taking a Jupyter notebook and transforming it into a DVC pipeline. So if you want to follow along, I think it'll be great fun and you can experience for yourself what this process looks like. Please go to this URL, which was also posted in the chat.
In the description. So yeah, just go below the video. There are links, and the first one says repository, and the link is there. Just click on this link.
Perfect. So then to get back to the question, what's the difference between MLflow and DVC? They share some similarities. To answer for DVC, it's an open source library that does your data versioning. It's not a hosted platform. So I think the main benefit is that you can use it free and use it in any way you like. So yeah, just give it a go and see what it does. MLflow does some other stuff. DVC fits into the iterative ecosystem that also offers a more complete package for your machine learning development process, or your MLOps process, I should say. But maybe you're only interested in just doing the data versioning or just doing the pipelines, and then you only need DVC. And then once you're interested in also doing model training online or creating a model registry, you can look towards other products such as CML or Iterative Studio. So it's a little bit more modular. And also it's not vendor locked. So you can use it with whatever stack you may have. Let's see, another question I saw. That seems useful when you have data on premise, but can we use the version data hosted elsewhere on the cloud, for example? So the data is in this case stored locally. You can mirror it to a cloud storage, for example, an S3 bucket. And it's also currently working on a more advanced product, DQL. I think, Dimitri, the CEO, emailed about this, I think, a week or two ago. Sign up to the newsletter if you want to learn more about that. Let's see, which looks like at least one duplication of primary data will always happen. Yes, that's true. So if you pull the data to your local system, then you are duplicating the data. And similarly, if you push it to your remote, then you are duplicating the data there. All right.
Just for those who watch it in replay, there will be no access to live chat. So the question that you just answered was about, like, if there is if you store the data in S3 and you do DVC pool, you don't load the data, so the data is kind of duplicated. So it's stored once in S3 and once on your local machine, right? That was the question, and this is what you answered, right?
Yes.
Okay.
Thanks for the recap. Yeah, so if you want to follow along, the link is in the description. Clone the Git repo. So we go to Documents. And I think I already cloned it. Yes, DVC workshop. So I don't need to do that part. And then we can open it here. File, open recent documents DVC workshop. And here we've got the exact same as we see online.
Maybe you can make this larger too, a bit.
Yeah.
Yeah. That's
is that good enough?
Oh, well, I mean, if you can enlarge it one more time, yeah, that's better.
It's not my favorite development experience, but we'll make it work. Let's close a few of these so we don't get any notifications popping up. So the first thing we need to do when we start a new project is just good practice is create a virtual environment for our dependencies. And all of these steps are, of course, listed in the README, as you can see here. So it's probably easiest to just copy the instructions if you want to follow along. Few notes: you need Python, and virtual env should also be installed. And I think it's a little bit lower. The notes on hardware. Actually, I'll just show it here because it's better formatted. So I'm working on a MacBook. So in my requirements, I'm using TensorFlow macOS and TensorFlow Metal. If you are not using a MacBook, I can't speak for every precise setup, but generally you will need TensorFlow. So make sure to replace that in the requirements.txt.
So we remove only, because there is TensorFlow macOS and TensorFlow Metal, so we replace TensorFlow Metal with TensorFlow macOS with TensorFlow and remove TensorFlow Metal, right?
Yeah, correct. Actually, it's the same as
test it now.
Right. So where were we? We were creating the virtual environment. And here my IDE automatically detects that I have created a virtual environment. We'll switch to it automatically, and we do that through source in activate. And now, as you can see here, we are working on a virtual environment, and we can start installing our requirements.txt. And here pip will automatically download packages. Let's see if there are any further questions thus far.
But there is another question that could be important. Is I also noticed that in your case you have TensorFlow 2.11.0, and in my case I have 2.9.
Oh, right. Yeah.
So that's requirements and requirements runner. These are different things.
Yeah. Don't worry about the requirements runner thus far. I had some errors with the TensorFlow macOS. This was what worked as I was working through it. There was a bit of a strange bug that I couldn't find. Like the solution I found online was, you need to downgrade to this version until they fix it. But it did this about 2 weeks ago, so I'm not quite sure what the status about this. From what I've tested, the spin versions here work well.
And then, coming back to this comment from Francisco. So I'm also on Windows and I'm following this tutorial. So what I did is, I just replaced TensorFlow macOS with TensorFlow and removed the Metal thing. And it is still installing.
Hey, there we go. Okay. I hope this is better for everyone who has troubles seeing the previous version. Okay. So let's see, where were we? We were installing so as you can see here, we installed our packages. And from there on out, we can continue. And we need to download the data. So if you are following along, there are 2 data sets on Kaggle. And you need to download those. I already did that. They're quite small data sets, by the way. So these 2, and we create a new folder, and we're placing them in data external. Let's see. And now we've got our Pokemon images here on which we'll be training the model. And this is our label data set, or at least it is, but we haven't processed it to look nice. So from here on out, we should be able to take a look at the notebook. And we're going to Pokemon classifier. So this notebook, as you can also run it online, I found this crashes a little bit less. So let's take a look. First, we do our imports. This is the moment of truth. Let's see how many errors we get along the way. We define some global variables. So for example, we are training for water type Pokemon. If anyone wants to wager a guess in the comments why we're going for water type Pokemon, you're happy to do so right now. It's a bit of a silly reasoning.
People might be busy downloading data and unpacking it. That's what I'm doing.
Yeah, I think so. No, it's class imbalance. The largest class in Pokemon are water Pokemon. So we're training a completely nonsense model. We're also validating on our training set, so the results don't really make sense from a data science point of view. But this is at least getting close to reasonable results. So from there on out, we just run through all the cells one by one. So this utility to such project routes. We create some directories we may need. And this is where it actually starts. So this is the data pre-processing. I won't go through all of these too in depth because it's not actually that important to have the to understand the contents of the cells before we start replacing them later on. Output exceeds size limits. Oh, that's fun. Did I not name this properly? Oh, right. So in the external, I didn't follow my instructions. This should be in the stats directory. So let's try that again. And as you can see, now we get our data set. So Pokedex, number, the Pokemon, which types they are, and then 1 hot encodings for every type. So for example, the first 3 Pokemon are grass, because that's the Bulbasaur line of evolution. And Squirtle, which is, the Charmander then, which is fire. Let's see, any more questions? Question in the chat to switch back to dark mode. We just switched to light mode, so people who saw a little bit less could follow it better. Generally, I also like my dark mode, but let's stick to this one for now. And yes, the other question by Lingo could not find TensorFlow macOS. I think you may need to downgrade your Python for that one.
For that, I guess it also depends where you run it. On Windows, it also didn't work for me. So I needed to replace it. Remember, if you're not on macOS, you need to replace it. Okay. Remove macOS part.
Oh, yeah, right. Let's continue with this part for now. So here we process the image data. So we copy over the image path because that's what we're training on. And then we have an image path, which you can see here in the process data as well. So for this specific example, it just copies over the data. It doesn't transform anything, but maybe you want to do some rescaling here, or you want to remove the transparent backgrounds in a typical machine learning project. That's where you do that. And here we create a trained test split. So here you go. We've got 801 Pokemon in the data sets. The images are 475 pixels by 475, and they've got 4 layers, so RGB and the alpha layer, because we are using transparent images. And we take a look at the labels, and we are interested in the type we're training for. So in our case, right now it's water, but we can change this later on to start training for other Pokemon types. Great test splits. So we've got 640 Pokemon in our training data set and 161 in our test data set. And this is something you don't typically do in a notebook, but we are doing now as an intermediary stage. So as I discussed earlier, if you use your DAG, so we do the data pre-processing stage, then that generates a bunch of outputs, and those outputs are, again, inputs for the next stage. So this is where we save the outputs of the pre-process stage as files. So this is a bit lazy, but we're just using pickle dumps. So we've got our training data set, xtrain and xtest, and we've got our labels, itrain and itest. This is the part that may take a while because the files can get a bit large. Oh, for this one, it's fine. It's great. And here we're doing some stuff. So we are using a convolutional neural network for this. This is where the data science magic happens. This is where you do your experimenting. For this one, prototype should work. It should give some sensible output. So we continue, and we can actually start training the model. This can take a while. Also depending on your platform, of course. It's fairly quick. I see lots of good tech support going on in chat, so always happy to see that.
Yeah, I'm still installing requirements. It takes a while.
Sorry, I should have sent this homework beforehand, maybe.
Yeah.
For the sake of recording,
something.
Oh, yeah, right. So. Yeah. For the sake of the recording, we will slowly continue, though. So we did training, and here we can plot some graphs of training. So, yeah, this kind of graph that you may recognize from your own projects, and we will save the model. In this case, I called it estimator, and we're again doing that as a pickle file. And then once we have the model saved, we can start predicting for Pokemon. So right here, we can see that Mudkip, it provides a score of 0.67, that it is in fact a water Pokemon. And that's true because Mudkip is a water Pokemon. So yay, we're making progress. Now let's validate the entire model. So this is again the first step of the validation stage or the evaluate stage, where we load in the data again, we load in the model. And then we can predict for all Pokemon. And once we have finished our prediction for each and every Pokemon, we can calculate our metrics. So our accuracy is quite good, actually, which shouldn't be strange because there's a lot of class imbalance. So your model could just say for every Pokemon is not a water Pokemon and would end up somewhere around here. Precision, not great. Recall is fine. Our F1 score. I mean, I wouldn't put this model to production, but it's a working example. And here's our confusion matrix. So that's our prototype, right? That's where we haven't done anything with DC, but we can go through our project and see how it works. Let's see. Pickle has a file limit size, I guess, for large file, so it might have problem pickling. Yes, that could be an issue. I think you can bypass it with your settings. I didn't run into this issue myself, I'm afraid. what psychopath uses pickle for data instead of e.g. parquet? Yeah, also a good question. Not the nicest formulation, I'm afraid, but it's easy to get this installed in your local environment, and generally it tends to work without too many issues. Again, use your own senses when developing something for production. Let's get to the interesting part of the workshop. We've got our notebook in place, and we can continue onwards. So this is where we start the actual workshop. We start implementing DVC. By running through our workbook, we created a bunch of data. We created pickle files for our data sets, or the train test split. We did our data transformation and created new images here. We even have a notebook. We have an output. So we've got our model saved right here. We've got our plots that we saw in the workbook earlier. So we have all of that, and now we want to start versioning here, because maybe I, from here on out, want to run an experiment with an increased number of epochs, or I know we want to train for dragon Pokemon. But as I do that in my notebook, then all of these get overwritten, and I don't want that. So now we start using DVC. And DVC is quite easy to get started. We already downloaded it in the previous step. Let's try to do this a little bit nicer. Now we run DVC init or initialize. You can now commit the change to Git. So right now DVC isn't doing anything yet. We still need to start tracking our data. And we start doing so with the external data set, because that's our input data. It's something we don't want to store in Git. And here we go. Let's not worry about this for now, but we have added the external data folder to DVC control. And what that has done is that all the files in external are now no longer tracked by Git. And we can also see that because if we go to git ignore here, the entire external directory is ignored by Git. But we have created a external.dvc metadata file. It's got a hash for the directory. It's got the size, which is the combined size of all files here. And it's got 906 files in them. So all of the Pokemon sprites and the CSV. What else can we do? We can take a look at Git status to see what that has done. So we've created a number of files in .dvc. So we've created the git ignore file. We've created our DVC config, which you can also take a look at. That's empty currently. And from here on out, we can commit our changes to Git. It's going to be, probably shouldn't have done Git at all, because the notebook file is a bit large. Let's start it again. Yeah, let's git add .dvc. Git commits. And now we can push them to our repository just like we could usually do. I should not have done that because we are still working on the main branch. That's very lousy of me. I'll fix that later on, but let's first do a git checkout to practice branch. And continue working from here. Question from Dino. Sorry, I joined a bit late. Other than models, what other data artifacts being stored in Git? So anything that's not a text file generally. So your data sets, your models, and in this case, also the training plots. Let's continue.
You mean in DVC, right? Because
sorry,
text stored in Git, but the rest is in DVC.
Yeah, thanks for keeping me sharp. But yeah, that's indeed the case. So we have committed our initialization of DVC, and now we can continue onwards. And we start by adding a remote storage for our DVC repository. So right now, if I were to delete the DTC workshop directory on my computer, then everything that we did would be lost. Much like if you only have a Git repository, stuff will be lost when you delete it. You need to mirror it to somewhere online. And at this point, the workshop starts to deviate a little bit for those who use something different. But I figured that the easiest way to get started would be to use a Google Drive remote. So let's take a look at that. Here we go. I've created a remote. There's already some data in there, but creating a Google Drive remote is fairly easy. We can create a folder. So let's call this one remote 2. We go there. And this is typically not something you want to do, but I don't want to get bumped down in access control right now. So the general access is going to be anyone with this link. And they even get to add it. Again, please don't do this in a production environment, but if you want to do this the proper way, then we need to set something up. So typically you'll get an S3 bucket maybe, or a bucket on any major cloud provider. You can also use Google Drive. That works well, but you need to create a service account or a credentials file that DVC can use to access this. It's not that difficult, but this is even easier. So right now we've got a fully accessible directory on Google Drive. And we need the folder ID, which is this part. If we go to, let's take a look here. If we go to the docs for remote add, I already opened that, we can see that this is a command we need to run. And if we scroll down a little bit, we get some information for all of the supported storage types. So again, you can use whatever you want. Also some self-hosted solutions. For now, we will use Google Drive. And for that, we need to do DVC remote add -D for making it default. So let's try all of that. DVC remote add. It's going to be a Google Drive remote. And we will need the, where did I leave it? Here. We will need the URI that we just created.
Do you not need to give it a name before the URL?
Oh, yeah. Trial and error. G Drive remote. Or just Drive remote. And as you can see, our Drive remote has been set as our default. Okay, so we done that part.
Can you send the link for this, like the one you like this one? Yeah.
Yeah, I will.
And maybe send it to chat, because I think spam filters will not let you publish links in the live chat. So send it to Zoom chat, and then I will post them in the live chat.
Okay. Okay. Let's see. Where is my chat?
Okay, I'll find it. Don't worry. I'll just Google it.
Here you go.
Ah, you found it. Okay.
Yeah, sorry. I don't typically use Zoom all that much, so it's a bit figuring out for me. But now that we've got a remote added, we can use DVC push just like you would use git push. So let's give that a go. Error. G Drive is not supported. Oh, that's annoying. So I actually did do this, but I need to restart the virtual environment. So depending on the remote you want to use, you need to specify in your requirements which remote you want to use. So the example includes all remotes, which is typically more than you would need in your project. But for now, we need the G Drive one. Let's give the DVC push another go, and there we go. Not exactly sure why this happens, but restarting the VM works. And as you can see right now, we are transferring all of the documents to our remote. So just like we have our cache, which includes all of these files. We also have that cache shortly on Google Drive, and we can showcase that by going to our remote. As you can see, the files are being created. We're first the directories, and we've got our image files right here. Now, as you will see, the image files don't make any sense whatsoever, and don't worry about that. That's the part that DVC handles. So it uses the hashes to see whether files have changed. So, for example, if I start drawing on Pikachu, then the image file will change, and it will get a new hash, and that's how DVC knows how to version your files properly. Anything else? Okay, nothing in the chat thus far. So let's continue. The DVC push is slowly processing, may depend on your internet speed, but we can continue. In the meantime, I should probably quit Google Chrome because I keep opening it by accident. We are now versioning our datasets with, our datasets and our models with DVC. So if we do our model training again, and we do a Git commit, and we do also a DVC push, then our new model training is saved on the remote, and we can go back to the one we are uploading now and reproduce that experiment that we just did. But we still don't have a pipeline. And we still need to go into the notebook to run through all the cells. And that's a bit of a hassle, which we don't want. So this is where the pipeline creation process starts. And first of all, we're going to create a params.yaml file. And DVC is going to read the parameters from this YAML file to determine which parameters to put into our machine learning experiment. So here we go, params.yaml. And as you can see, these are the same parameters, maybe slightly different names, as we had in the notebook earlier. So again, we can do a git commit. Right, yeah, data and outputs aren't yet tracked by DVC. I lied earlier, we are only tracking the input data, and there's good reason for that, but we'll get to that later. So what did we change? We created a params.yaml file, and we do want to add that to our Git commit history. Git commits, create params.yaml. Okay, we have our params.yaml in place, and this is where we start breaking up the notebook. So as we discussed earlier, we've got 4 distinct stages, each with their own outputs, the outputs of which are an input for the next stage. And we are going to break them up into Python modules. So we're going to have 4 stages: data preprocess, data load, train, and evaluate. And for the sake of time, I will copy over the stuff I did before this. Typically, what the process will look is you will just go into your notebook, copy the relevant parts, and put them in a Python module. And then we need some boilerplate around it to make it work. It's magic. So if we go here, you can't see this, and that's fine. Where are we? SRC, there we go. So we create a SRC folder, which is typically where your Python modules are created. We are going to create a utils, which is a bit of boilerplate that helps in this project. Sorry, this should be a directory, of course. And in utils, we are going to create find projects routes.py. This is also a cell in the workbook or the notebook. And then in the regular SRC folder, we are going to create a data preprocess stage. And we are going to create a let's copy that. We are going to create a data load stage. we are going to create a training stage, a training module, and we are going to create a test. No, sorry, let's call that evaluates because that's what I'm using in the other ones as well. Then from our notebook, as I described, you go there. It's getting a little bit cluttered on the screen. But for example, for data preprocessing, this is stuff we're interested in copying over. And I've already done that somewhere else. And this is the highly varying part depending on the prototype you're actually working on. So also in the descriptions for the workshop or the instructions, you'll find a link to the solutions. It's probably easiest to copy them over, at least for now, but we will discuss what exactly is going on.
It's in a different branch or where to find the solution?
It's in the solution branch, yeah.
In the solution branch, okay.
So first, the data preprocess. I'm going to zoom out a little bit, sorry, just to get a better idea. We still have our imports that we need to do. This is the util we just created so that it's always working in the same directory. This is what we copied over. And then all the way at the bottom, we've got our main function. And the main function is what is triggered when we run the Python module from our command line. We do some argument parsing. This is just copy-paste boilerplate. Here we import our parameters. So the params.yaml. And here we set our variable, the variables that we need, depending on the contents of our params.yaml. And once we've got all of that in place, we can start running the functions we defined above. So if we train it, save this. Let's see. Yeah, this is also described here. Then you can use this command to run the Python module. So if we go to our terminal, we use Python 3, src, data preprocess, and params is in params.yaml. No module named pandas. Import pandas as PD. Was that not included in the?
Because you don't. Your
sorry. Yeah.
Not activated.
It's
probably another terminal, right?
Yes, I love having tech support right on the line.
That's why you should use pipin.
Very sharp, yeah. Okay, so that's my learning out of this workshop. Manage my virtual environments better. I'd be happy to see the link pop up right now, Alexi, in the recording. So we've got our source, and we can try this again. So now, fingers crossed, live demos. Yes, there you go. These are the outputs as we got them, but now we're getting them in a terminal. And we can do this for each of the stages. So we already did data preprocess. Now let's copy over the data loads. And again, we create a main function. We do this, repeat the same boilerplate. We need some other variables here. So these are done here. And also we need some of the outputs that we wrote in the previous stage. Oh, no, sorry, that's only in the next stage. So here we are pickle dumping the stuff that is our outputs. If we then go to train, which I will also copy over, the same stuff is going on here, but now we have pickle loads for our outputs from the previous step. And then there's the final stage we need to do, which is evaluate. There we go. And again, we copy over the stuff from our notebooks. Here, most of the action happens in the main function. So we load load the outputs of the previous stages that we need. We do a model prediction. We create metrics, and then we save those metrics as a metrics YAML file. And we print them as well to our terminal. Right. So let's save all of these. We'll close them. And now we can run each model from our command line, which is a little bit better than going into the notebook to run the cells one after the other. But still, we want to do this in one subsequent manner. So we want to be able to run the entire pipeline with one command. And at this point, you may ask, okay, I can just write a script that runs those commands after one another. But it's a little bit easier to do this with DVC. Or rather a little bit quicker, because DVC caches your outputs for each stage. So, for example, if our data set doesn't change throughout various experiments, then we don't need to run the data loading and the data preprocessing stage each and every time. So if we add, I don't know, an extra layer to our training our model, then we only need to run the last two steps of our DAG of our pipeline. And that's why we use DVC, because it can speed up your development by caching the outputs. Let's take a quick look at the chat. Are there any more questions? The copy and pasting is error prone. Yes, that is indeed error prone. There are some tools that allow for automatic transforming or automatic transformation of the notebook. I've also written a blog post, which I think was linked in the description of the event or the invitation, where we wrap the entire notebook and run it as one, but that doesn't provide you the benefits of caching the outputs. Sorry, you want to jump in?
Yeah, you still need to, like, if you have one big notebook, it's still a lot of manual work to decompose it into multiple modules, right?
Yes,
and I don't know,
correct.
like, if there is any automatic way to do this. At the end, it's still like a developer or a data scientist, machine learning engineer, who needs to do that, right?
Yeah, I also I already see a suggestion popping up in chat. So NBDev, yes, I haven't used that myself, so I can't really speak for it.
Yeah, I will look it up. Well, what I typically do is I use this command that comes with Jupyter called nbconvert, and you do Jupyter nbconvert to script, and then it just takes your IPB file and turns it into Python script, and then you just copy paste different things. Essentially, it's what you did, but then you have it already in a Python script.
Yeah, probably the nicer way to do this. This workshop will have been a success for me if at this point I am actively convincing you not to get to the point where you've got this huge notebook going on. So if at a certain point you think, hey, this is getting a bit bloated, maybe transform this into a DVC pipeline. Then I'll be happy about this. Because probably, as I said all the way at the beginning of this workshop, notebooks are great for prototyping, but at a certain point you need to realize, oh, this is growing beyond just prototyping. I need to actively experiment. And that's probably where you want to start worrying about this stuff.
I think
from there on out.
And BDEV is like a replacement for, like, there are people who like running notebooks in production. We actually also do this at the company where I work. Yeah, there are tools for that, and I think NBDev is one of such tools. But I guess DVC does not play nice with these things.
No, because for notebooks, it's so every time you run a notebook, it contains metadata that gets updated. So versioning notebooks is a bit of a hassle, and there are tools to strip those metadata and make it more reproducible. But the DVC way is to define your pipeline as code. Know what's going on, so that you can version everything with either Git or DVC. Let's move beyond using notebooks. Actually, we could just delete those if we were so inclined, and let's start using the modules we created. So if we go back to our instructions, we start creating the pipeline. And this is what your typical pipeline looks like. Pipeline is defined in dvc.yaml. So we create the dvc.yaml, and then we need to define our dependencies, our outputs, the params that we pass to it, and we do that for every stage. So again, I have already done this, which is also linked here. So this is what it will look like. Let's copy it over, and then we can quickly go through it. New file, dvc.yaml. So we've got our stages: first data pre-processing, then data loading, etc. For each stage, we execute a command, which is exactly the same as we would execute it from our terminal. And in order to execute this stage, we have a number of dependencies. So for the data pre-processing stage, that's the existence of data preprocess.py. So we actually want the module to exist. We also want our external data to exist, so the images and the CSV with labels. Then we know that our module is going to create a number of outputs, and those are going to be data processed Pokemon CSV, another CSV with image paths. Probably should have structured this a little bit differently, but that's fine. And then our processed image files. And in order to execute this command, we need a number of parameters from our params.yaml. And those are the base section. So let's take a look at params.yaml. So the base and everything we need in data preprocess. So we are constructing a label for water here. So we need to know that parameter and then this stuff. So these are our file paths, so that DVC knows where to find Python in this case, knows where to find the data that we need. Yes. Okay. Then we do that for every step. For the next step, rather than only having dependence outputs, we also have the dependencies from the previous step. So as you can see here, the data processed occurs as an output in this stage and as a dependency in the next one. And through this, you can create quite extensive DAGs, like the one we're using right now is just a straight line, 4 stages subsequently. But at a certain point, you may get to a project where you can execute 2 stages separately from another. And then they can both be dependent on the stage above it, and the stage below them can be dependent on both of those. And this is how you manage that. We pass some other parameters, and we do this for each one of the stages. And then this is a little bit different. For the evaluation, we create a metrics output. And a metrics output is a YAML file in this case. We were already generating this in the notebook, but we are now explicitly saying that this is a metrics file. And we do that so that we can compare experiments with DVC from the command line. So one of the metrics, for example, is F1. And if we specify that metrics.yaml is in fact a metrics file, DVC will let us compare those F1 scores across different experiments. So we've got a pipeline defined as code here. Let's see, we don't need to keep opening new terminals, but let's put it to the test. How do we reproduce our pipeline? Nothing has changed, but we can run through it. Oh, wait, sorry. Actually, let's do one other thing. DVC DAG. So this is the DAG visually that DVC constructs from your dvc.yaml file. Now let's do DVC reproduce. And it's going to run through all of those stages. DVC isn't aware that we've run the stages individually yet, so it's going to run through them one by one. And it's going to take a little while. So let's see if there are any other questions right now. I don't think so, unless I'm overlooking something.
There were, but I took care of them.
Oh, nice.
So there was, maybe for those who watch it in replay, all these files that Rob created, they are available in the solution branch. So go to the link that is in the description, then switch to a different branch, and then you can get all the files from there.
You would actually just show this.
Yeah.
So we've got main here, go to solution. There we've got everything already set up.
Yeah, and then another question was, or more like a comment about a tool called LinearPy, which is, I think, like it's not related to DVC in any way, but that's another tool that you can use for transforming like notebooks in pipelines.
Cool. I'll need to look up that one as well. Yeah. I've got a lot of homework out of this workshop.
Yeah, thanks a lot for bringing all these things up. The other one was NBDev, right?
Yes, I think so. Yeah.
Finished.
There we go. Evaluation done. Accuracy, even better than it used to be. So that's our pipeline. And now we can go through it with DVC reproduce. But as you will see here, we've also got another way of running experiments. So first of all, what we could do now is start running experiments by going to our params.yaml and saying, okay, and for the next Pokemon version, for Pokemon Scarlet, I'm not interested in becoming a water trainer, but I want to be a bug catcher. So let's change this to bug. And then if we do DVC repro again, it will see that our parameters have changed. So that we do, in fact, want to rerun a number of stages. Let's not go through all of this again. This is not the best way to do this. Sorry, let's also show one in the later stages. So water, for example, if we do a different let's do a different learning rate.
Before you do this, I'm just wondering if we should commit the results of the previous run, so then we kind of see the changes in the metrics.
No, let's not do that yet. Okay. Sorry, I cut off the...
Getting a bit ahead?
Yeah. Because ideally, I wouldn't recommend using this way to run experiments. Mm-hmm. So instead, let's try this one. As you can see, now I only changed something in the train set. So DVC knows that preprocess hasn't changed. And also that data load is cached. So we can just skip those and go straight towards training the model. Let's wrap this one up because it's going quite quickly. And then meanwhile, we can look at the other way, which I think is the recommended way of doing so, or it is recommended way of doing so, and the way I think you should be doing so. And that's by running experiments. So we can trigger a new experiment, not by going into the parameters and changing something manually, but by using DVC exp run. And then with the S option, capital S, we can set a parameter. So for example, this experiment would run the entire pipeline, but for becoming a dragon type trainer. So let's try that one as well. And at that point, we get different experiments. So we've got a workspace, which is currently a water type trainer, the previous run we did with an increased learning rate. And we are now doing another experiment. Becoming dragon type trainer with otherwise the same parameters. And the way DVC experiments work, they can create a branch. They don't necessarily have to create a branch. So you can mess around, try different experiments. And as I will show shortly, we can then compare those experiments, pick the best one, and promote those to a branch in our Git commit history. Let's take a quick breather as this runs again.
Yeah, well, since it finished. I was going to ask you about one of the questions, if you have any experience with deploying PyTorch models. Because I kind of sent the person who asked that to DataTalks Club Slack. But I don't know, do you have any experience with PyTorch?
Not myself, no, I'm afraid. I know I don't want to toot iteratives more too much, but take a look at my lab, nlem.ai, because that is a package also free and open source that makes it easier to deploy our models to production.
just send it to live chat.
Yeah. Okay, so now we can compare those experiments because we've just run 2 of them, and we can do so with DVC show. And this will generate a model. So we've got our workspace, and we've got the experiment we just ran. And currently, our workspace is also the experiment. Sorry, you were right. I should have committed the other one earlier. Let's do another one for water. And in the meantime, I would like to point all of you, because thus far we've been working in, this one was cache, so that's nice. In the meantime, we've been working with our terminal thus far. So here we've got our experiments overview. And these 2 experiments have different outcomes. But what works a little bit better, here you can see one for water, one for dragon. What works better, or at least what I prefer using, is the DVC extension for VS Code, which contains, it's a visual approach to what we have been doing thus far. But here we can compare our experiments visually. So we've got our 2 experiments here, and previous commits if we want to look at them. Honestly, I wasn't even aware that this has been released yet, but we can also define our pipelines from here, apparently. You can connect to Studio, the SaaS offering for iterative. Let's not get into that too much.
To install it, we just go to the extensions tab and then type DVC.
Oh, yeah, that's a good one. How do you get there? Go to the extensions tab, DVC,
okay,
and you can install it here.
Can you go full screen with VS Code?
Yes, yeah. Of course. Sorry.
More space.
A question: I see hyperparams hard-coded in the params.yaml. I think that should be DVC, maybe.
That's probably DVC,
yeah. Yeah. So the exactly the hyperparameters are hard-coded here, but if we run an experiment, then it updates those parameters in this file. So then if we go to our Git commit history, we can take a look at different commits and see, we should go to solution. We can take a look at different commits and then see what those parameters were at a given point in time. So for example, for the current commit in our solutions, if we go to params.yaml, we can see that our test size was 0.2 and our batch size was 120. Now, if we change these in a different experiment, actually, let's show that. So let's see what we have got. So this should all be good to add. Let's remove the notebooks because we don't really need those anymore. Git add dash, git commits, experiments. What we're retraining this one, increase learning rates. Git push, and then I'll get an error. There we go.
Probably also didn't want to push the models, but I guess it's...
yeah, so the models...
like, weren't they supposed to be picked up by DVC?
Yeah, the models aren't being pushed to Git. So yeah, that's good that you mentioned that. Because only the text files are being pushed there, or at least they should be. It's going to be a bit of a slip up if I mess this one up. But the model is defined as an output. So the saved model is automatically tracked by DVC. You don't need to add it to DVC control. If it's an output in a DVC pipeline, then it is added to DVC. And so if we now do DVC push, which I won't do because it's going to take a while, it will push the model file to our DVC remote.
So does it automatically add it to git ignore when you do git add dot? It knows
Yes.
that. Okay.
Yeah.
So it knows that it should be ignored and not added.
Yeah. Every file is either tracked by DVC or by Git, or so primarily by Git and otherwise by DVC if you tell DVC to track it. And if you tell DVC to track it, either it's through using DVC add or by adding it as a cached pipeline output, then DVC automatically adds it to your git ignore.
That's smart.
So then we can take a look here. So as we discussed earlier, we now know for this commit in this specific branch what our hyperparameters were. And then if we go to branches, there should now be a practice branch, the one we've been working on. Then we can now see in this given commit that we have been experimenting with our learning rates. I think that's one we updated anyway. I said it was this one.
I think the question, maybe I misunderstood it, but I think the question was when you do it through the command line interface, when you change, because I remember you could also change the parameter there, right? You can specify the parameter. Will it also update the YAML file?
Yeah, it will.
Uh-huh.
Actually, we can show that. Where are we? Let's close this terminal. So right now, we were experimenting with water Pokemon. So if we go to browse the YAML, we will see water here. And let's go for, I don't know, ice Pokemon. Let's freeze them over. Then here, DVC will change the browse the YAML. Woo. Magic code. So if we take a look at our tutorial again, then that leaves us at the end of our module 1 for the workshop. We have now transformed our entire pipeline into a reproducible DVC pipeline where all files are either tracked and versioned by Git or by DVC, and we can easily run experiments, compare their outcomes, and promote experiments to a feature branch in Git, in our Git repository. So I would recommend exploring the DVC extension for Visual Studio, maybe yourself. It's got the same principles, or it's the same inner mechanics, but through a nicer interface, which may make it a little bit more approachable if you want to use this. And I think Alex also showed this in the previous guides, right? Or workshop.
Yeah, there was a workshop from Alex Kim about what's the name? I'll look it up right now, and we'll put the
let's link it in the description. So let's take a look at the time. We are running a bit short, which is what I was afraid of, I must admit. But this workshop, the pipeline can also be taken online. So I don't know, Alexei, if we can't wrap this up in the 12-ish minutes that we have remaining.
If it takes a bit longer, if you can stay longer, I don't know. That's fine. Okay,
let's try the basics first, and then the advanced stuff can be found in the workshop description, because that's going to take some configuring for AWS or GCP as well. So in that case, I just want to show how to create a workflow YAML file and use that YAML file to trigger scripts, which can also be our DVC pipeline from our GitHub actions. So if you still need to do so, you can go to settings here. Then on the left-hand side, you've got actions, general, and then you need to enable workflows here. For me, they're already enabled in this repository. And as we can see in the descriptions, we can then create a workflow. Let's close all of this. That's a bit too much. So this is our file structure again. And we can create GitHub here. Oh, sorry, it shouldn't go in SRC. That should go to the root. And then we should create a workflows directory there. And this is specifically to GitHub, but similar workflows can be found in GitLab or in Bitbucket. They are named a bit different. This should be a file, I'm sorry. It should be a directory. And then let's copy this boilerplate example. So GitHub allows you to define actions for your CSD as YAML. So we will not use push here, we will just use workflow dispatch. But there are triggers that you can use. So for example, if you use push, then every time you push changes to your repository on GitHub, the pipeline will automatically trigger. Workflow dispatch is manually. So that's a button like, hey, I want to run this pipeline. And we define a job there. A job, just like any pipeline, consists of a sequence of stages. For now, we're just going to do train and report. It's going to run on Ubuntu. It's going to have a DVC base. And here you can define which commands it executes. So for just a basic example, it's not actually going to do anything. It's just going to provide some textual feedback.
And then I added a link. I put the link to the previous workshop we had with Alex, where he shows like how to use DVC, CML, and other things, and this DVC extension. So the link is in the live chat and in the description, and there you can see, I guess, more advanced example of CML.
Yeah, nice. So create a basic workflow, and we push that to Git as well. Or, we push that to GitHub, I should say. And now if you go to the workshop and we go to practice, then we can take a look at actions. And we will see that we have created, am I in the right branch? Does not distinguish here between. Oh no, actually I think that's correct. Oh, that's interesting. What's going on here? Okay, let's. I'm not sure what I'm doing wrong. Let's not worry about this. This is what you should see when you push this. So you can go to the workflow file, which is the same as we just implemented. And it's going to do something. And GitHub provides free runners that you can use to run your stuff. That being said, they do have some hardware limitations. So if you are doing any serious model training, you probably do want to do so on provisioned hardware. And that's where CML comes in, because it makes it very easy to do that. This is the sort of output that you should see. It's executing commands, and you're getting something back. Just like you can use something, you can use your terminal to run something locally. You can use this approach to run stuff on GitHub hardware. And we can expand upon the echo command to run more advanced stuff, such as DVC reproduce or DVC exp run. And that's where it gets interesting. I won't demo this live, but I will show you what it should look like roughly after you do some configuration. Because if we go to solution, I've created a example workflow that does something more. So let's walk through this quickly. We again use workflow dispatch so that we can trigger this workflow whenever we want to with push of a button. We can also do it with push whenever we push code changes. And there's a whole list of triggers that you can use to start your workflow. You could also schedule your model training. So a use case that's quite interesting, I think, is if you want to redo your model training periodically, you can create a workflow that pulls in your data, your latest data, do your model training, and create a new branch to see if your model is still performing well, and compare it against previous model runs. So with CML, we can CML allows us to tailor this specifically to machine learning workflows. So we're doing a pipeline in 2 stages. First, we're deploying a runner, and then we're training our model. And let's take a look at the trained model first, counterintuitively. What we're doing here is we are setting up our model training. We are providing some credentials. So these are the credentials that are needed to access the DVC remote I created earlier on Google Drive, this one. And for that, you'll need to set up a service account. Similarly, if you're using, for example, an S3 bucket, you will need to provide your credentials, or you will need to generate credentials and provide them in your GitOps secrets so that DVC can access the data. Once you've got it all set up, you can run scripts just as you could run them from your terminal. So you can, on the runner, install your requirements, you can pull your data there, you can reproduce the pipeline, you can push the results back to the remote. And then CML allows you to create a pull request that displays visually the performance of your machine learning experiment. So, for example, you could create a pull request that automatically generates, has an automatically generated confusion metrics in it, your metrics, and then through commits, you can compare which model training is performing better and decide which one to keep, for example. Now, why do we do that on different hardware? What CML allows you to do is deploy a runner quite easily. So you provide your access credentials. In this case, I chose AWS here because that's what we use as iterative. You need an access key ID and a secret. All of those are added in your secrets over here for actions. So right now it's not working because it didn't add those secrets. But personal access token is here, and GitHub will automatically paste in the values for those secrets. And then CML allows us to provision a runner on which we will execute our training stage. So rather than using GitHub Actions itself or the runner that GitHub provides, we are creating our own. And we are going to do so on an AWS machine located in Western Europe. We can define our cloud type, and it's going to be single use. So right after model training, we just throw it out. We don't want to see the runner again. And that's going to reduce your cloud expenditure because your cloud instances don't keep running all the time. Now, I realize that all of this is a bit much to fly through. So in the workshop description, you can find some more materials to go about this. I didn't update this part. I will put some materials here. Alternatively, you can go to iterative AI to our blog and take a look at CML. And this is the one. This is a blog post I wrote that takes you through this process. And it teaches you, or it's a guide to let you do model training, create a pull request whenever you do your model training. And also in part 2 of this, make sure that the model is saved to your DVC repository.
Please send the link to Zoom chat.
Yes. Let's do it straight away.
And then again, also, after checking this blog post, you can check the workshop from Alex, where he also shows how to use CML. Yeah, I'm going to put it now to the description. Oh, there are 2 links.
Yeah, it's a 2-part blog post. So let's see. Question from Shamina. Can we automatically retrain model if input data changes in some way? Yes. So DVC's DAG is and cache is file-based. So it calculates a hash for every file. So DVC will only it's all or nothing. So if anything changed in your input data and you do model training, then it will detect that your input data changed, so it will run the entire pipeline. Model distributions is a little bit more difficult. I think there are other tools that you could probably combine DVC with to achieve that. Ways or commands to retrieve are different specific models, which are versions.
Sorry,
Oh,
I'm just wanted to add to your previous point. Like, isn't it what CML is for? Like, you change something, you push, and then like, will it not detect that there are some changes and they retrain the model?
yes, but like I can imagine that you have a database somewhere, and you anytime your distribution in your database changes, then you want to return your model. What you could do with CML is run a periodic check, like, oh, every week I want to see what has happened with my input data, and take it from there. You could probably also build some checks there.
Here you need a system that detects drift, right? And then
exactly
invokes DVC.
Yeah. So ways to commands to retrieve are different specific models which are first used in DVC. That's a really good question, which I'd still like to answer. So let's close this. So conceptually, our experiment is now tied to a Git commit. So here we've got a given experiment name, S27 something, and that contains a certain version for every for the code, for the data, for the parameters, and our outputs. So if we want to change our model that is currently in our workspace, all we need to do is do git checkout to a different commit, which can be in a different branch or in the same branch. Just do git checkout, and then use DVC checkout, and DVC will restore from its cache the model, the parameters, or sorry, not the parameters, the data to your workspace. And what we can also do is, if your colleague or a coworker or a teammate has done that, and they have pushed the commits or the experiments to GitHub and to the DVC remote, then you can pull the data from there with DVC pull. I hope
I'm
that
wondering
that
if there is a way to, like when you do git checkout, you might accidentally forget to do DVC checkout, right?
Yeah, you can configure DVC to do that automatically.
Okay. You mean like when you do git checkout, you would like it would automatically?
Exactly.
That's cool.
Cool. I think it's sort of on time. We didn't get to cover everything. CML is a little bit more involved because it's really, for what it does, it's really easy to get started. But you will still need to set up your cloud environment, generate some credentials, add them as secrets. So it's difficult to work that into a workshop. But I hope the instructions provide a starting point to get going with that.
Yeah. Well, the most important part we did cover, right? And now knowing the basics of DVC, like it's possible to put it to CML and experiment with this.
Let's see. I don't see any further questions in chat.
Yeah, there are no. So does it mean we should conclude? Because we're a bit over time. So I wanted to thank you. That's a great workshop. Thanks also everyone for joining us, for being active, for asking questions. Rob, do you want to say anything before we finish?
Yeah, you're fishing for what I want to say. So sadly, I was laid off by Iterative last week. So I'm looking for a job in DevRel, preferably with data science, MLOps, that kind of space. I really enjoyed doing what I did. But it is what it is, working on a startup. So should you have any leads, please let me know. I'd be happy to receive those. And of course, feel free to reach out on LinkedIn, send me a message. Just also if you want to connect and stay in touch.
Yeah, that was a great workshop. So you would be missing out if you don't reach out to Rob.
Thanks.
Because you might have to have a DevRel like him on your team.
Yeah, still available. Get him all top.
So I will also put your LinkedIn in the links.
Yeah, that would be great.
Yeah. Great workshop. Thanks again. And well, I don't know what else to say.
Just thanks for having me. And
thanks
see you next time.
Yeah, see you next time. Okay.
Bye.
Thanks for watching. If you enjoyed this product update video, please like and subscribe. Thanks, Stevie. And feel free to post comments and questions below. On our YouTube channel, we share videos on product updates, tutorials, and how members of our community use our tools as they solve problems in their domains spanning a wide variety of fields in the machine learning and AI space. Don't miss out on any of it. See the description below to find links in the docs for our tools. They are an excellent resource for getting started. Also visit our blog where you can find tutorials on our tools as well as product and company news. Join our Discord server to get support, help others grappling with the same issues as you, connect with other like-minded folks, and discuss our tools or other topics in the MLOps space. It's a great way to learn and get to know others worldwide who share your interests. We also have a job channel where you can find relevant job opportunities in the space. Finally, if you're really serious about taking your MLOps skills to the next level, we offer a free online course that is designed to help you understand the iterative philosophy and achieve your MLOps goals. Our mission at Iterative is to deliver the best developer experience for machine learning teams by developing an ecosystem of open, modular ML tools. Thanks for making it to the end. Devi and I will see you in the next video.